Okay guys, welcome back. So in the last video I explained to you about some examples to remind you about the basic concepts of inequalities. So in that video I actually talked to you, I actually explained to you about inequalities of linear expressions when the expression that is being used is of power 1, or you are using linear algebraic expressions and you are taking the inequality. Now what actually happens when you are given something greater than 1, the power of greater than 1, whether it's a quadratic equation or whether it's a cubic equation. So I'll not go to the concept of cubic equations because it is beyond the concept that we have been discussing on the levels of inequalities. So I'll talk to you only about the next theory or the next level of inequalities, which are the solutions or solving the inequalities of quadratic expressions. So let's take a simple example, quadratic expressions. So I'll take some quadratic expression, something x squared plus 5x plus 4. So that's the quadratic equation that I'll be using, and I'll take this to be greater than 0. Now if you are given something like this, how can you solve for x? Now you can't get an exact value for x because this is an inequality, this is not an equation. If this was an equation, you can easily solve for x using the fact either from factorization, completing squares, from the general quadratic solution equation, you have many options to solve this if this is an equation. But if you have an inequality like this, whether this is greater than 0, less than 0, greater than or equal to 0, or less than or equal to 0, or that means if you have some inequality, how we can solve this. So that will be the theme or the main topic of this video. Alright. So this is the example that I will be using, a simple example in which the coefficient of the quadratic expression is 1. Alright. So x squared plus 5x plus 4 is greater than 0. Now you know that if this was equal to 0, how to find the solutions. So let's find the solution when this is equal to 0 first of all. So that's the first thing that you need to know. So I'll take some panel or something like this, right? So I'll take x squared plus 5x plus 4 is equal to 0. I'm taking this as a separate division because this is actually beyond the solutions of this inequality. But you need the values of these to find the inequality. But these are actually doing for an equation. So you have to separate this. So it will be easy if you are doing it. If you are actually thinking of redoing it, or if you are checking whether it's correct or something like that. It will be easy to divide it into parts where you actually don't need as steps, the solutions of these as steps. So x squared plus 5x plus 4 is equal to 0. So in order to find the solutions, the easiest way is to factorize this. So the solutions will be x plus 4 and x plus 1, and those will be equal to 0. So when x plus 4 times x plus 1 is 0, you know how to find the solutions. You have to equate these separately into 0. So x plus 4 is equal to 0 as well as x plus 1 is equal to 0. So first of all I'll solve for this. So when x plus 4 is equal to 0, x is equal to minus 4. So this is one solution. And also when x plus 1 is equal to 0, we can say x is equal to minus 1. This is another solution. We'll extend the panel. Right? X is equal to minus 1. Alright. So these are the two solutions if this expression is equal to 0. Now what if this is not equal to 0? So if this is an inequality. So if this is an inequality, what you will find is, first of all, as the first step, you have to draw a number line. Draw the x-axis. So the solutions, first of all, at the second step, you have to denote the solutions. So the first solution I will take it to be minus 1. I'll take something to be minus 1 here, and the second solution is minus 4. Excuse me, maybe minus 4, right? Then what I will do here is, now I have to denote this in the in the terms of this one, right? So what I will do here is that if x square plus 5x plus 4 is greater than 0, what I can say is that x plus 1 or x plus 1 times x plus 4 should also be greater than 0. Right? You found that because you actually factorized here, right? Whether this is equal to 0, greater than 0, anything, right? X squared plus 5x plus 4 can be factorized as x plus 4 times x plus 1. No, x plus 1 times x plus 4. So you factorized here as x plus 1 times x plus 4, and since there's a greater than 0, you have to take it similarly here. So you have to find the solutions. You find in the solutions of this inequality is the same as finding the solutions of this inequality. So first of all, what you have to do is that now you found the values when it is equal to 0, you have to find the values when it is greater than 0. So you have to divide this as the third step, as the fourth step of finding the solution. You have to do what you have to do is you have to divide this into different divisions. Like this. And then as the fifth step, what you have to do is that you have to actually find the value of this expression within each of these ranges. So that's quite interesting, right? Now if I take a value between, now here the range, the right limit is minus 4 here, and the left limit is negative infinity, right, or minus infinity, and within this range the left limit is minus 4 and the right limit is minus 1, and within this range the left limit is minus 1 and the right limit is positive infinity. So if I take the limit range, this limit between negative infinity or minus infinity and minus 4, if I substitute some value here, what will happen, right? So I take this to be y equals x plus 1 times x plus 4. Now what I actually do is I have to find the value, the sign of y within each of these ranges. Now I have 3 ranges, so within my first range I'll take the value that is between minus 4 and minus infinity. I'll take the value of say minus 5, right? Minus 5. So minus 5 is between minus 4 and minus infinity. So if I substitute minus 5 in place of x, what I will get here is minus 5 plus 1, which is minus 4. So this part will be minus. So here will be minus, right? Minus, and this part minus 5 plus 4 is equal to minus 1. So this term is also minus. So y will be minus times minus some value. I don't need the value, I actually need only the sign. So y will be positive within this range. Similarly, between minus 4 and minus 1, if I take some value, say minus 2, so minus 2 is between minus 1 and minus 4. If I substitute minus 2 here in place of x, so if x is equal to minus 2 plus 1 is equal to minus 1. So this bracket will become minus, and minus 2 plus 4 is equal to positive 2. So this will be positive. So I actually need the sign, not the magnitude. So minus times positive, right? Minus times, or the negative times positive, or minus times plus will be negative. So y will be negative within this range. And in this range between minus 1 and positive infinity, I will take 0. 0 is the easiest way to solve. So 0 plus 1 is positive. So this bracket will become positive. And this bracket 0 plus 4 is positive 4. So this bracket will also become positive. So positive times positive is positive. So y will be positive. Right? So if y is equal to x plus 1 times x plus 4, so this is the same as here. So what I actually need is the values so that x plus 1 times x plus 4 is greater than 0. So since y is equal to x plus 1 times x plus 4, I need the values where y is greater than 0. Y is greater than 0. So y is greater than 0 is the same as y is positive. So y is positive only within these two ranges, so the solutions of y will be such that y is actually less than minus 4 solution, and y is greater than minus 1. Now this is not equal because we have been given an inequality where this is not equal, so these two will not be equal, right? These two will not be equal, so the final solution will be something like this. So since y is less than minus 4, the solutions of this will be something like this. Here you get a minus 1, minus 4, the x-axis. So since this is only greater than, you have an uncolored circle, and since this is greater than, you have to color this range. And minus 4 also here, since this is only less than, you have to color, you have an uncolored circle, and since this inequality is less than, you have to color this range. Right? So these will be the solutions of this quadratic equation when it is greater than 0. So if you are denoting in set notation, what you can say is that x belongs to the range when this is, you can't actually equate, right? Whether this is equal or whether this is not equal, you can't equate this to negative infinity. So always the negative infinity will be of a curly bracket here, curve bracket, minus infinity, between minus infinity and minus 4. And since this is not equal to minus 4, you have another curve bracket. Union shows that another part belongs to this one, and since this is not equal to minus 1, the left limit will be minus 1, and you will have a curve bracket, and the right hand side limit is positive infinity, and you cannot equate it to positive infinity, so it will be another curve bracket. So this is the way if you are denoting in set notation, right? So this is the graphical way. This is using the set notation. So any value between negative infinity and negative 4 and negative 1 and positive infinity will satisfy this inequality. And this video explains you. I explained to you as to how you can solve. Now in the last video I explained to you about the solutions of algebraic expressions when the expression is linear algebraic expressions, or in the form of ax plus b. Now I explained to you in this video about solving inequalities when it is in the form ax squared plus bx plus c, or quadratic expressions when they are unequal to some value. And in the next video I will be talking about some similar concepts, but I will be talking about some examples of quotient functions as inequalities. Now I explained to you about linear functions as inequalities, quadratic function as inequalities. Now I will merge these two, combine these two, and I will explain to you about quotient functions as inequalities. See you then.